Hi, my name is Alif Haronudin Ismail. Metric number is B022110090.
Hi, my name is Alif Haronudin and my number metric is B022110168.
So for the construction, first we saw down a few blocks to make it as a base for our components. It's stated that R, D and O, which is regulator, diode and out. So next is we glue the components onto the board. Then we also glue the plastic wheel to the brush DC motor. This is for it to act as the rotary. This is for the DC motor to act as a gear connection with the bicycle wheels. Then we do the soldering process, which we glued the component on the board just now. Then we drill some holes on the motor block and we tie it with the cable tie to make it secure. This is to prevent it from moving around, which will disturb the system. In this clip, I apply a few cable ties between the DC motor and the wooden board for it to stay still. And this is the result of the distribution board and also the motor board. So this is a comparison between an unregulated DC voltage output and regulated DC voltage output. So in this clip, I didn't use any voltage regulator which outputs the average voltage of 7 volts. So in this next clip, I use voltage regulator LM7805 which outputs 5 voltage output and it shows an average of 4.4 volts. So the output voltage is suitable for normal USB load which needs 5 volt output and 1 ampere. Hi, so now I'm going to explain about the working principle. First, you can see here. Come a little closer. This is the power generating board. So as the wheel rotates, the DC motor with the wheel here also rotates and produce power. So I tied a bunch of cable tie here to secure its position so it will not move during the rotation of the tire. As the wheel turns, it will produce power, voltage and supply it to the LM7805. The LM will limits the voltage maximum up to 5 volts. The 5 volts sends it to the diode. The diode is to prevent any reverse current, prevent the load from burning. Then from the diode, USB port. Then the USB port, you can either put any load such as phone charger, or in this case we use USB box, LED box. So it depends on your type of load. So that's pretty much it for the working principle of this electric generator. Thank you.
I am going to demonstrate our project. For the better experience, I will turn off the light so that you can see the lights clearly. Okay, right now I'm going to show you how we want to charge this power bank using our electric generator. So the percentage level you can see is 0%, and I will insert this USB cable to the USB port. Put in the power bank in the safe place. And we can see the result after a few minutes.
Now I'm going to test run.
So as you can see, after 5 minutes right, the percentage is increased to the 2%. For the further improvement of our project, we can add on some IC to make the voltage output more stabilized. It is to prevent the battery from damaging. And second one is the gear system over here. We are using the tire from the bicycle and tire from the DC motor. Because of the frictional between this tire, it make the tire at the DC motor become bald, and maybe we can improve the quality of the tire at the DC motor. And the last one is we can improve the power distribution board. We can add housing or casing over here to prevent it from the water damaging. Also external forces that we might not know from outside. Okay, that's all from us. Thank you.